Okay. Good morning, everyone. Good morning, Kawe. Good morning, Robert. Good morning, Trust. Good morning to everyone else viewing. Okay. So we'll be handling integration today. Yeah, we'll be handling integration, power rule, use substitution. Yeah. Good morning, Maximina. Good morning, Kapindula. Welcome to Quantum. Leah, good morning. Diana never misses a lesson. I think when I get my pension, I think I'll buy you a lollipop. All right. And if there are people who won from last session, I don't know. I lost. I couldn't remember the names. So just if you won in the last session, I think about 3 or 2 people, text me. You get your airtime. Okay. Yeah. All right. Dismas, good morning. Mulenga B Chichi, good morning. Okay, so when we have 40 people viewing, we will start. Yeah, so you guys have to make the most of what's happening now. You get? Learning online is not efficient. Obviously, it's not the perfect way to learn. Yeah, and as Quantum, there are 2 ways you can learn online. We can have these videos. Jonathan, good morning. Angela Muleta, good morning. Yeah, we can have these videos or you can do the documents. When you see that maybe we are not having a session and so on, please make a date to start ticking those topics off, those documents off your checklist. Okay? Make sure you study each and every document that there is, especially those that joined us in term 2. Search for the links for term 1 and the like. Start studying them. Then when you get into Telegram, you need to scroll up for you to see the notes. Okay, so for those complaining that they can't see the notes so they can see our names, just scroll up, you see the notes. Okay, so we have 50 people viewing. I think we can start integration. Okay. All right. Okay. Prince, good morning. Let's go. So, integration. So, integration basically has 2 parts. We can have definite integrals or indefinite. Okay. Now, definite integrals have limits. Okay. Indefinite integrals, no limits. Okay. So, what is a limit? You understand? If I want you to integrate, they are going to use this symbol. They're going to use this symbol, pa. That means they want you to integrate something. Now, what they want you to focus on is the letter that comes after the d. So you'll be given a function, f of x. So if they want you to focus on x, after the d, we're going to have an x. If they put integral, they put dy, then they want you to focus on y. Okay. What is a limit? A limit is a number that's written on top and a number that is written below. You get? Those are limits. So if you don't have anything written on top or below the integral sign, then you are dealing with an integral, with an indefinite integral. It doesn't have limits. Okay? And when you don't have limits, you always add plus c to your answer. Okay? Though this looks like repetition, add plus, but it's okay. Data and data. So add plus c to your answer. Then, if you have limits, you will have to substitute the upper limit subtract, then substitute the lower limit. Okay, so these are the differences between definite integrals and indefinite integrals. So if you see your lecturers use these big words, oh, find the definite. Greenwell, good morning. find the definite integral, find the indefinite integral. Like, you know what they mean. They just basically mean you either have limits or you don't. If you don't have limits, put a C at the end of your answer. If you have limits, you have to use this mnemonic SSS. Substitute, subtract, substitute. Okay, easy stuff. So let's start with the power rule. The power rule. So everything I'm going to teach you for now is going to be based on indefinite integrals. Okay, because if you understand indefinite integrals, all we have to do is a very, very small shift for you to apply concepts under definite integrals. So the power rule. So the power rule states that add 1 to the power then subtract add 1 to the power then divide. Okay, divide everything by the new power. Okay, what do we mean? We've been given we've been asked to integrate ax to the power n. Okay, so here we have a and we have x. So if they put dA, then they want you to add 1 to the power of a and divide everything by the power of a. If they put dx, they want you to add 1 to the power of x and divide everything by the power of x. Now, we put a dx here, meaning our focus is x. Whenever you're not focusing on something, write it in front of the integral sign. Like the a we are not going to add anything to the power of a, we're not going to divide anything by the power of a. So the a is not our focus. So if something is not your focus, write it in front of the integral sign. So this is going to become a integral x to the power n dx. Okay. Now, this integral sign and the dx, they are telling us to add 1 to the power of x and divide everything by the power of x. The moment I add 1 and divide everything by the power, the dx and the integral sign disappear. Okay, so this is going to be, so a integral of x n dx is going to give us, I'm going to add 1 to the power of x, which is n. This becomes x to the power n plus 1. Then I'll divide everything by the new power, which is n plus 1, divided by n plus 1. I didn't have limits. I didn't have a number on top. I didn't have a number below. Okay. So I'm going to add a c. We are done. So the integral sign and the dx disappear the moment you add 1 to the power and divide everything by the new power. The power rule is done. But then there's one limitation regarding the power rule. The power rule has one limitation. Okay. Limitations of the power rule. Okay. Limitations of the power rule. Oh, sorry. The A will be written in front. So you just get a x to the power n plus 1 over n plus 1 then plus c. Okay, do not forget about the a. Good. So, limitations of the power rule. The power rule does not work when n is equal to -1. Okay, what do we get when we add 1 to -1? What do we get when we add 1 to -1? What do we get? So quickly comment. What do we get when we add 1 to -1? What do we get when we add 1 to -1? We get 0. Good. Meaning, if I had integral of a x to the power n plus 1, integral of a x to the power n dx. Integrating this, we're going to get a integral of x n dx. The integral and the dx are telling us to add 1 to the power and then divide everything by the new power. So we are going to get a multiplied by x to the power n plus 1, okay, divide everything by n plus 1. then plus c. Now, what if n is -1? Let me try substituting n with -1. So I'm going to get a x to the power -1 plus 1 divided by -1 plus 1 plus c. Okay, we focus on this. We said -1 plus 1 is going to give us 0. -1 plus 1 is going to give us 0. So this expression is actually going to become a x to the power 0, divide everything by 0. Now, in mathematics, remember I told you there are 3 taboos in math. 0 should never be a denominator, okay? A Z should never be a denominator. A complex number should never be a denominator. What do we get when 0 is our denominator? What do we get when 0 is our denominator? What do we get when 0 is our denominator? When 0 is our denominator in mathematics, what do we get? What do we get when 0 is our denominator? Anyone with an idea? Whenever 0 is our denominator, we say the function is what? The function is undefined. This doesn't make sense. This doesn't make sense. Okay, so remember, we've said the limitation of the power rule is it can be applied when n is -1. But how do we integrate functions where n is going to be -1? Okay, integrating functions when n is equal to -1. So here's what to do. Okay, so number 1. Make the item with a power of -1 become a denominator. You know, when something has a negative power, it should actually be a denominator. So become a denominator. Okay. Then simply make that denominator the middle item of ln. Chap. Simply make that denominator the middle item of ln. Now, for you to understand some of the terms I'll be using, you should have studied logarithms using my documents, obviously. You get? So, when we say the middle item, we are going to have a log, we're going to have a base, and what comes after the base, we are going to refer to it as the middle item. You get? So, simply get the denominator and make it the middle item of ln. Basically that. Okay. So, let's do an example. Let's do a few examples. So, integrate the following. Integrate the following. So A, I want you to find the integral of 3x squared dx. Okay. B, I want you to find the integral of x cubed plus 5x plus 3 dx. And then C, I want us to find the integral of 1 over x. C dx. D, they want us to find the integral of -3 over x plus 1 dx. Okay, so we're going to handle these. So the first one is very easy, very easy. So we have integral of 3x squared dx. Now we said the 3 is not really part of the integration that we're going to do, so you can write it in front of the integral sign. This is going to be 3 integral of x squared dx. I'm going to add 1 to the power of x, so this is going to be give me 2 plus 1. So this is going to give me 3 multiplied by x to the power 2 plus 1, divide everything by 2 plus 1. Okay, when I'm done integrating, I can add a c at the end. So this is going to give me 3 This is going to be x cubed divided by 3, then there's a plus c. This 3 and this 3 can cancel out. The answer is just going to be x cubed plus c. Okay. Previous page. Here, integrating functions when n is -1. Make the item with the power of -1 become a denominator. Okay? Then simply make that denominator the middle item of ln. So all this will make sense when we actually do a question. It will make sense. Okay, let's go. Let's go. So we are done with part A. Part B. Part B, they're asking us to find the integral of x cubed plus 5x plus 3 with respect to x, because it is an x that comes after the d. Okay. Now, integrating a whole function like this is as good as integrating each item with respect to x. So it's like the integral sign and the dx will apply to the x cubed, they'll apply to the 5x, they'll apply to the 3. So this is as good as having integral of x cubed dx plus integral of 5x dx plus integral of 3 dx. You see that? And we don't have limits, so at the end we are supposed to add a c. I'll add 1 to the power. This is going to give me x to the power 4, divide everything by 4. Plus, here, I'll add 1. If I want, I can put the 5 in front, but with time, you learn how to do these things quickly. Okay. This is going to be, this already has a power 1, so if I add 1, it's going to be x squared. This is going to be 5x squared divided by 2. Plus, now, let's focus on the 3. The 3 doesn't have, so it's the reverse of differentiating a log. Yes, basically that. So the 3 doesn't really have an x, but it has 1. Okay? If I write 3 is as good as x to having x to the power 0. Just that whenever you have x to the power 0, that item isn't actually there. You understand? So, if I have 3x to the power 0, whenever a letter, or rather, whenever a number doesn't have a letter, then that letter is actually there, but it only has a power of 0. So I'll add 1 to this 0, and then I'll divide everything by 0 plus 1. You get? So let me just show you what I've done. So this is going to be 3x 0 plus 1, divide everything by 0 plus 1. We didn't have limits throughout, so I am going to add a c at the end. So simplifying. So this is going to give me x to the power 4 over 4 plus 5x squared over 2 plus, here, 0 plus 1 is just going to be 1. So this is going to be 3x to the power 1, divide everything by 0 plus 1, this is just going to be 1, plus c. Whenever 1 is a power, we don't really write it. Whenever 1 is a denominator, we just ignore it. So the simple form of this is going to be x to the power 4 over 4 plus 5x squared over 2 plus 3x plus c. In simple terms, if you differentiate a number with respect to a letter, that letter simply appears or attaches itself to that number. You get? So that's B. Let's quickly do C. So C, we are now going to apply the rule of introducing a log. And what log did we say we introduce when we have a power of -1? You can comment. What log did we say we introduce when we have a power of -1? What log did we say we introduce when we have a power of -1? What log did we say we introduce when we have a power of -1? What log did we say we introduce when we have a power of -1? Yeah, ln. And we know that ln is actually log base e. Those that went to expensive schools would say lean, but it's okay. Data and data. All right, let's go. So they're asking us to integrate. Find the integral of 1 over x dx, okay? So if this was to come in this form, the alternative way that this question would come, they would say find the integral of x to the power -1 dx. So sometimes it having a power of -1 could actually be hidden. You understand? Yeah. So if something is a denominator and you bring it on top, it's going to have a power of -1. And we can't use the power rule here because we're going to end up with something undefined. You get? So take this back to the original form in which it was. Like, make this item that has the power of -1 become a denominator. So this should be written like that, so that the x is actually a denominator. Then we said, simply pick the middle item, okay, and simply pick the denominator and make it the middle item of ln. You get? And we describe the middle item as what comes after the log. So the answer for this is basically just going to be ln, the middle item is going to be x. Now, the denominator, the middle item of a log should always be positive. The middle item of a log should always be positive. So ln x would be correct, but to just make sure your answers are always positive, you're going to put the middle item in modulus bars. I hope this is making sense. And then you put a plus c. So let me just do this again. What if you are asked to integrate, find the integral of 2 over x dx? Okay, so if you have any number other than 1, you're going to write it in front of the integral sign. You're going to have 2 integral of 1 over x dx. This x has the potential to have a power of -1. Whenever you have such being the case, you simply get the denominator and make it the middle item of x. Then to make sure it's always positive, you're going to put it in modulus bars. So this is going to be 2 ln, we get the denominator and we make it the middle item of ln. So this is going to be x. We need to make sure what comes after the log is always positive. So I'll put this in modulus bars. You get? Then because we didn't have limits, we add a c. I hope this makes sense. I hope this makes sense. Just, you guys, I would like you to try something. What is the integral of -3 over t dt? What is the answer to this? -3 over t dt. What do you think could be the answer to that? -3 over t dt. Just try that out. Quickly. So don't be confused. The same way we would use the x is the same way we are using t. So don't be confused by the change in variables. Yeah, Prince. Good. So -3 ln will become x. Yeah, divided by x. Yeah. So, good. You needed to add a plus c. Yeah, good. So the answer to this, we're going to factor out the -3 integral of 1 over t dt. This t has the potential to have a power of -1. So the answer to this is going to be -3 multiplied by ln modulus of t. Then we didn't have limits, so we add a c. So never forget to add a c. The moment you forget, your whole method could be marked wrong. You get? Okay, let's go. There's one other question. D, part D. Part D was integral of -3 over x plus 1. Okay. Now, x plus 1 dx. Look at the denominator as a whole, as 1. Okay? So we'll be taking this denominator, will either move up or come back down, like at the same time. The x is attached to the 1. You get? If I bring this x plus 1 on top, this is actually going to give me integral of -3 x plus 1 to the power -1 dx. So you see, this has the potential to have a power of -1. And whenever something has the potential to have a power of -1, I'm simply going to write the denominator, make the denominator the middle item of ln. So maybe you guys can also try this. What do you think is going to be the answer for this? What do you think is going to be the answer for this? Don't get confused. The way you handled it for t is the way you're going to handle it for x plus 1. Take x plus 1 as a whole. like it's the whole denominator. What do you think is going to be the answer for this? We need to make sure you guys are following so that we know we are doing the right thing. What do you think is going to be the answer there? Negative 3 modulus of x plus 1 mwalabako ka ln. Okay, and then for Kim, you don't use square brackets, use modulus bars. Okay, yes, Angela has gotten it. So this is going to be negative 3 ln. This denominator is going to be our middle item. That is going to be x plus 1. We need to make sure what comes after the log is positive. So we're going to put it in modulus bars. And then we add a plus c because we didn't have limits. Excellent stuff. Easy, easy, easy stuff. So the power rule is done. Okay, so I'm going to ask this question. What is one limitation of the power rule? When can't we use the power rule? What is one limitation of the power rule? When can't we use the power rule? Quickly. What is one limitation of the power rule? When can't we use the power rule? When can't we use the power rule? When can't we use the power rule? When is it forbidden for us to use the power rule? Okay, so when n is negative, not really negative, it has to be a specific negative number. The power rule can work if n is negative 1. Okay, so that you guys don't get confused. There's a difference. Look, we can have integral of 1 over x plus 1. And we can have integral of 1 over x plus 1 squared dx. Do not use the limitation on this. You understand? Do not use the limitation on this. The limitation will only apply when the power has the ability to become negative 1. This one that has a power of 2, we're going to learn a new method. So n has to be a specific value, n has to be negative 1 for the power rule value. Okay, so we're done with the power rule. We start with U substitution. U substitution. Okay, so your U is the denominator or the complicated part. Once you choose U, don't worry don't worry don't worry about whatever is left. By the grace of God, what is left will disappear. Will disappear. Okay, so U is the denominator or the complicated part. Once you choose U, don't worry about whatever is left. Okay, so by the grace of God, what is left will disappear. Good. So let's go. Remember, I gave you a question recently. I said find the integral of 1 over x plus 1 squared dx. If I make this x plus 1 become a denominator, it's actually going to give me integral over x plus 1 to the power negative 2 dx. Can I use the power rule on this? Like, can I use the limitation of the power rule on this? Can I introduce ln on the answer for this question? Does it make sense for me to introduce ln on the answer for this question? Just yes or no. Can I introduce ln here for this question? Can I introduce ln for this question? No. You only introduce ln when the power is -1. If you have -2, you don't use the limitation. You understand? So for this, we are going to use what we call the U substitution. Okay? U substitution. So, what's inside the complicated part is going to be taken to be our U. Now, when you are doing the U substitution, you make two substitutions. So U substitution. So we said U is the complicated part, the denominator, or the complicated part. Okay? We make two replacements. We make two replacements. Okay? What are these two replacements that we make? Number one, you replace the denominator or complicated part with U. Okay? Then number two, replace dx with a du expression. Replace dx with a du expression. Why can't we use the power rule? No, we're still going to use the power rule, except we are going to have to bring in something easier. You're going to see. You are going to see. We are going to see. We're still going to use the power rule, but we won't use the power rule just the way the question is appearing. We need to alter a few things. You're going to see. So U substitution. These are very important pointers. So for U substitution, U is the denominator of the complicated part. We make two replacements. Okay? Number one, replace the denominator or the complicated part with U. Next, replace dx with a du expression. Okay? Then in brackets you can say we get the du expression by differentiating the u we chose. So how do we get the du expression? How do we get the du expression? You can just copy what I've written here. I just want to make sure you guys are following. How do we get the du expression? We get the du expression by blah, blah, blah. How do we get the du expression? How do we get the du expression? So we make two replacements. Replace the denominator or the complicated part with u. Then replace dx with the du expression. How do we get the du expression? We get the du expression by blah, blah, blah. How do we get the du expression? How do we get the du expression? For those that like taking screenshots, this is your chance to take screenshots. How do we get the du expression? By differentiating the u that we choose. You understand? We get the du expression by differentiating the u that we choose. Okay. So let me show you what I mean by this. So I said let's try to integrate integral of 1 over x plus 1 squared dx. We need to make two replacements. Okay? The denominator here is going to be the denominator of the complicated item. The x plus 1 here is what we're going to replace with our u. So we're going to say let u be x plus 1. You understand? Now, we need to differentiate u. But we have an expression where u is the subject and we have x as the variable. So if I differentiate u, I should differentiate it with respect to x. So you guys should be very careful. Right? When integrating, there are elements of differentiating. So we've chosen what's inside the denominator as our u. Okay? We said let u be x plus 1. We're going to differentiate u with respect to x. This means du over dx of all this expression is going to be, what is the derivative of x plus 1 with respect to x? What is the derivative of x plus 1 with respect to x? What is the derivative of x plus 1 with respect to x? What is the derivative of x plus 1 with respect to x? Are you sure the answer is x? No? You're going to differentiate 1, you're going to differentiate x. What's the derivative of x plus 1 with respect to x? What is the derivative of x plus 1 with respect to x? Good. The answer is going to be 1. The derivative of x is just 1. The 1 will give us 0. So the answer will just be 1. So du over dx of this expression is going to be 1. You see that? Now, we are trying to make two substitutions. We're replacing the denominator with u, and we want to replace dx with a du expression. You understand? I know where I have x plus 1, I can put a u. But the dx should disappear. The only way dx can disappear is if I find something to replace it with. You get? So, I've gotten du over dx is equal to 1. I need to make dx a subject of the formula. This is as good as over 1. We cross multiply. I get du is equal to, okay, 1 du is equal to 1 dx. Okay? I'm trying to make dx a subject of a formula. I'll divide both sides by 1. This is going to give me dx is equal to 1 du. Okay? Or I can just say du. So I am going to make two replacements. I'll replace the denominator or the complicated item with u. So let me do that replacement. This is going to be integral of 1 over. So what's inside is going to be u. Don't forget we had a power of 2 outside. 2. Dx, I'm going to replace dx with a du expression. What did we say dx is equal to? What do I replace dx with? I've replaced the complicated item with u. Okay? What do I replace dx with? What do I replace dx with? Let's go. What do I replace dx with? I'm going to replace dx with 1 du or du. It's the same, right? So where there's dx, because dx is equal to 1 du, this is just as good as dx is equal to du. So wherever there's dx, I'm going to put what dx is represented by. So I'm going to put du. Okay. Now, this is a denominator, and if I bring it up, it won't give me a power of -1. The only time the power rule is invalid, or the only limitation for the power rule, is when you have a power of -1. But here we're going to have -2. So this is going to be integral of, so this u to a power 2 is going to come on top, and we're going to have u to a power -2 du. You get? Yeah. So the power rule, we said we add 1 to the power and then divide everything by the new power. And it makes sense. Look, I'm going to have dx if I'm differentiating an expression that has x in it. The moment I replace all the x's with u, okay, even the dx that I had should disappear. I should replace the dx with du. Okay, so this makes sense. This u squared is going to come on top. I get u to the power -2. So if we had 2x, does that mean we would replace dx with 2x du? If we had 2x, where 2x? Oh, 2x du. I don't really get your question. Okay, so we're going to add 1 to the power, divide everything by the new power. So this is going to be u to the power negative 2 plus 1. Okay, divide everything by the new power, which is negative 2 plus 1. Don't forget we didn't have limits, so I'm going to add a c. Negative 2 plus 1, if we evaluate it, it won't give us 0. Okay, so this is going to be u to the power negative 1 over negative 2 plus 1 is going to be negative 1. Okay, plus c. Now, if something has a power of negative 1, it means that thing should actually be a denominator. So this is going to be, this u to the power negative 1 should become a denominator. So it's going to be, now, if what was on top disappears, I'll be left with a 1 on top. So I'm going to have 1 over negative 1. This u to the power negative 1 will come down. It will just be negative 1u plus c. Okay? And remember that your u was x plus 1. So you just introduced u, so u should eventually disappear. So this is going to give us, 1. Actually, this negative can become the numerator's sign. So negative 1 over u. Where there's u, I can put x plus 1. So negative 1 over x plus 1. Then we add a plus c. Easy stuff. So that's how we would integrate that. Now we'll come back to use substitution. Firstly, let me teach you trigonometric integration, and then we apply use substitution on trigonometric functions. I hope you guys are following properly. These are just rules. We're just laying the foundation for the real stuff. Okay, so trigonometric integration. Trigonometric integration. Okay, trig integration. So trig integration can be divided, okay, into, I would call them simple integrations. Okay, simple integrations. And then we can have B, integrations requiring u substitution, and then C, integrations for products of certain trig functions. Okay, so we'll start with the simple ones, and then we'll go to relatively tough ones, and then we'll go to the toughest. Okay, so simple ones, simple integrations. So simple integrations, this is the integral of cos, integral of sine, you get? So we're going to have the integral of sine x dx. We're going to have the integral of a sine, we're going to have the integral of sine ax. We are going to have the integral of cos x dx. We are going to have integral of cos ax dx. So these four simple integrals. Now, for simple integrals, we are going to use the mnemonic computer science. Computer science. You understand? What mnemonic did we use for the differentiation of trig functions? Who remembers the mnemonic that we used for the differentiation of trig functions? So you need to know these two mnemonics. When you're differentiating, what mnemonic do we use? When you're integrating, what mnemonic do we use? So what mnemonic did we use for the differentiation of trig functions? What mnemonic did we use for the differentiation of trig functions? We use the mnemonic state cancel. Differentiating sine will give us positive cos. Differentiating cos will give us negative sine. It's good people can remember these things. Now, we have introduced a new mnemonic, and this mnemonic is for integration. So do not mix up the mnemonic for differentiation with the mnemonic for integration. Okay, so when you integrate cos, you are going to get positive sign because they're moving in the normal way in which things should move. But if we differentiate sine, we are going to get negative cos. Okay, so the mnemonic that we use for the integration of simple trigonometric functions is computer science. If I integrate sine x, I am moving from S, I am going to go to C. What do you think is going to be the answer for the integral of sine x if I'm moving against the mnemonic? What do you think is going to be the answer for the integral of sine x? Just try. What do you think is going to be the answer for the integral of sine x? What do you think is going to be the answer for the integral of sine x? Negative cos x. But we don't have limits, so you should always add a c. Okay, so the answer here, we're moving against the mnemonic, so from S to C, we get a negative. We get negative cos x. Okay, we didn't have limits, so we're going to have to add a c. Okay, easy stuff. Now, when we integrate sine ax, we still get negative cos, but then there's something that comes in. Okay, the integral of sine ax, the answer is going to be negative a cos ax plus c. So what the coefficient of x becomes the coefficient of everything but still remains the coefficient of x. The coefficient of x becomes the coefficient of everything but still remains the coefficient of x. The coefficient of x becomes the coefficient of everything but still remains the coefficient of x. Okay. Oh, sorry, not this. We're going to have 1 over a. Let me just write this properly so that you guys are not confused. You know, it's very easy to mix up differentiation with integration. So we said integral of sine x dx is going to be negative cos x, okay, plus c. Integral of sine ax dx, okay, this is going to be negative 1 over a. You understand? Negative 1 over a cos ax plus c. So if we were differentiating this, yes, the a would just become the coefficient. But when we are integrating, the a becomes like 1 over, like it becomes a denominator. You understand? Okay. So these rules, I think you just need to know them. You will just need to know them. Let's go. Integral of cos x. What is the answer for the integral of cos x with respect to x? What do you think is the answer for the integral of cos x with respect to x? Sine. Good. Because the mnemonic is computer science, so the answer is going to be positive. So the answer is going to be sine x plus c. Integral of cos ax dx is going to be 1 over a sine ax then plus c. So basically these are the integrals of simple trigonometric functions. Okay, these are the integrals of simple trigonometric functions. Now let's try and apply this knowledge when finding the integral of tan. You know, tan isn't as simple as it appears. You get? Just like the derivative of tan is not straightforward, you need to use the quotient rule. Just like the integral of tan is not straightforward, you need to use U substitution. Okay. Let's try finding the integral of tan. Integral of tan x with respect to x. Now, whenever you see tan, what should you replace it with? Whenever you see tan, what should you replace it with? Whenever you see tan, what should you replace it with? Whenever you see tan, what should you replace it with? You should replace it with sin x over cos x. So this is as good as integral of sin x over cos x, and then we're going to have a dx. Now, we have something that has a denominator, okay? And the previous question that we did, where we couldn't really use the power rule directly, we used the U substitution, okay? Now, how do we choose U when using U substitution? How do we choose U? What is our U? How do we choose U for U substitution? So pay attention to it. How do we choose U for U substitution? How do we tell that, oh, this should be our U? So for the U substitution, how do we tell that, okay, this should be our U? U is either the denominator or the complicated item. In this case, we'll go for the denominator. You understand? Meaning our U is going to be cos x. We make two replacements. So we will use the U substitution. And then just to see if you guys are following, the U substitution, we said we make two replacements. Okay? What are those two replacements that we make? What are those two replacements that we make when we are using the U substitution? We're going to replace something and then replace another thing. What are the two replacements that we make when we are using the U substitution? What are the two replacements that we make when we are using the U substitution? What are the two replacements that we make when we are using the U substitution? Replace the denominator with U, yes. So replace the denominator with U. Replace the denominator with U. And then the second thing, we are going to replace dx with, now, you don't just replace dx with du. I said replace dx with a du expression. Okay, let me emphasize that. You don't just replace dx with du. You need to replace dx with a du expression. Okay, replace dx with a du expression. You get? Replace dx with a du expression. So, what do you think is going to be our u if we look at the integral of sin x over cos x dx? What do you think is going to be our u? What do you think is going to be our u when integrating this? What do you think is going to be our u? What do you think is going to be our u? Our u is going to be cos x. So we're going to select u be cos x. Now, we get dx by differentiating we get a du expression by differentiating the u that we have. We've said our u, so this is our u, yes. Now we need something to replace dx with. We said we are going to replace dx with a du expression. We get a du expression by differentiating u. Let me write that. We get the du expression by differentiating u. Okay. So if I differentiate u, what am I going to get? Du over dx. I'm differentiating u with respect to x. That's why I've written du over dx. So what is the derivative of cos x? This is where you need to be careful. We are integrating, but in integration, we have components of integration. Or rather, we are integrating, but in integrating, we have components of differentiation. So you need to quickly switch from integration to differentiation and back. So this part requires us to differentiate. And in differentiating, we said we use the mnemonic state cancel. Okay, so what is the derivative of cos? Negative sine, good. So this is going to be negative sine x. So the derivative of u with respect to x is going to give us negative sine x. Now, mind you, I told you we need to replace two things. I need to replace the denominator with u, and I need to replace dx with a du expression. I found my denominator to be cos x, and that's going to be my u. I differentiate u, I get du over dx. I need something to replace dx with, meaning in this derivative, I need to make dx the subject so that I can just replace it there. Okay, I'm looking for something to replace dx with. To replace dx, you differentiate u. I get this. Then I make dx the subject. This is going to be, this is as good as over 1 cross multiply. Negative sine x dx is equal to du. Okay, I want to make dx the subject, so I'm going to divide both sides by negative sine x by negative sine x. So I end up with dx is equal to, this negative can be written on top. Negative du over sine x. So I am going to replace the denominator with u. I'll replace cos x with u. So let me do that replacement. Integral of sine x over u. Okay, I have replaced the denominator with u. Next, I should replace dx with a du expression. I get the du expression by differentiating the u that I picked. So it's like the dx and the u are always connected. Okay, I differentiate the u, I end up with du over dx is equal to negative sine x. I need to make dx a subject because I want to replace it. So I end up with dx is equal to negative du over sine x. Remember, I told you, don't worry about whatever is left. Anything else that is left that has an x, it always disappears. You get? So I'm going to replace dx with what it is represented by. Dx is represented by negative du over sine x. So this would be times negative du over sine x. I told you, don't worry about whatever is left. It always disappears. So the sine x was left and it has disappeared. So this sine x can cancel out with that sine x. You see that? Don't forget there's a negative here. Okay? And if there's no number, we can just put a 1 so that we make our work easier. So this becomes integral of negative 1 over u du. Okay? The negative 1 can be factored out. We're going to get negative 1 integral of 1 over u du. You get? So here we can apply the power rule, but if you look properly, this is one of the limitations of the power rule. You understand? This u, if it were to come on top, is going to have a power of negative 1. So whenever something has the ability to have a power of negative 1, you simply make it the middle item of ln. And don't forget there's a negative 1 outside. So this is going to give us negative 1. This denominator is going to become the middle item of ln. We're going to have ln modulus of u, because we need to make sure whatever comes after ln is positive. Okay, then we add a c. Now we are not done. We said u is cos x. You understand? So wherever we are going to have u, because u was not originally there in the equation. So it needs to disappear. So I'm going to replace u with what it originally was. So the final answer is going to be -1 ln modulus of cos x plus c. Easy stuff. That is our answer. That is our answer. That is our answer. So I hope this is making sense. I hope this is making sense. Let me quickly do another question. Let me quickly do another question. So let's find the integral of cot x dx. Cot, what can cot be written as? 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 Good. So cot can be written as cos x over sin x dx. What is my u? What is my u in this case? What is my u? This is not a simple integration. It's an integration that would require us to use the u substitution. What is our u for this expression? What is our u? So our u is sin x, yes. So integral of cos x over sin x dx. The denominator of the complicated part is our u. So we're going to say let u be sin x. Then I'm going to make two replacements. I'll replace the denominator with u and I'll replace dx with a du expression. Okay? How do I get my du expression? How do I get a du expression? How do I get a du expression? How do I get a du expression? What do I do to get a du expression? What do I do to get a du expression? What do I do to get a du expression? To get a du expression, I'm going to differentiate my u with respect to x. Good. So this becomes du over dx is equal to, now differentiation, you quickly need to switch from integration to differentiation, and for differentiation we use the mnemonic state cancel. Okay, so if we use state cancel, we're differentiating sign, we're going to get positive cos. Make dx a substitute formula, over 1 we cross multiply, we get dx cos x is equal to du. I'm trying to make dx a subject, so I'll divide this side by cos x, I'll divide this side by cos x. So this becomes dx is equal to du over cos x. So I make those two replacements. Where there's sin x, I put u. Where there's dx, I put a du expression. So this becomes integral. Don't worry about whatever is left. It always disappears. This is going to give us cos x over u. Where there's dx, I'm going to put du over cos x. As I told you, whatever is left has disappeared. We have cos as a numerator, cos as a denominator. So these will cancel out. So this is going to be integral of 1 over u du. Okay. Yeah. Now, this u has the potential to give us a power of -1. And whenever anything has a potential to give us a power of -1, we simply introduce ln. Understand? So the answer for this is going to be ln modulus of u And then we didn't have limits, so we add a plus c. If you remember, our u was sin x. So I can say this is going to be ln modulus of sin x plus c. Easy stuff. Does that make sense? Does that make sense? Does that make sense? Does that make sense? So let's try answering an exam question together. Ooh, I don't think I have it now. I may need to look for it. Okay. All right. So, you guys understand how to handle the u substitution, okay? And you guys understand that tan is not just tan, it's actually sine over cos. You guys understand that cot is not just cot, it's actually, cot is not just cot, it's actually cos over sine. Good. Now, I told you that there are 3 types of integrals under trigonometry. So we are going to have simple integrals. That is where we use the mnemonic computer science. We're going to have integrals requiring u substitution. You get? That is where we integrate tan and cot. Then integrations for products of certain trig functions. Okay. So we are going to use a mnemonic that we call the boogeyman. You guys may have seen it in the document. Integrals of products of certain trig functions. Of certain trig functions. Okay. Integrals of products of certain trig functions. So we use a mnemonic, the boogeyman. Okay, some people would say the boogerman. All right, so this mnemonic is like this. You may have seen it in the document. How many of you can remember this? There's a document on calculus. Yes, there is a document on calculus. Yeah, so this is going to be a nostril. This is going to be another nostril. Okay, this is an eye, so I'm just going to put sec. We're going to put sec. Okay, and then because this is a tank, there's a small label where they've said tank. And because this is a tank, we have water dripping. And you know, wherever there's water, this is June, we expect someone to be shivering. If you saw this, just say something if you saw it, so that you can actually appreciate what this mnemonic means. So this dude is shivering. This dude is shivering. Now, you only shiver if it is cold. And the word cold sounds like one of the trig ratios, which is cot. The word tank sounds like one of those trig ratios, which is basically tan. So on top we have sec, sec, tan. Below, we're going to have cosec. And in this nostril, who remembers what was in this nostril? Who remembers what was in this nostril? Just type it up. Who remembers what was in that nostril? Who remembers what was in this nostril? Who remembers? Who remembers what was in this other nostril? There was something, like if you saw and read the document, or even just browse through it. You should have seen it like, what was in this nostril? There's something that was in that nostril. Who remembers? Do money have a job? Because someone who truly wanted to learn calculus would have at least tried to study whatever little they could from that document. Who remembers what was in this nostril? You can type it up. It doesn't matter. Who remembers what was in this nostril? There was something. There was something. Who remembers? Don't worry, don't be judged. Just type it up. Who remembers what was in this nostril? And the shame. Those that said you saw the mnemonic. Who remembers what was in this nostril? Something was coming out of this nostril in the mnemonic. Who remembers? And the shame there was negative cosec, but then there was also something that was coming from here. There's something that you could see visually. Apart from the negative cosec, what else was there? Where is the document? Okay, so we are going to do this. We are going to have a short break. And I'm going to allow you guys to take a look. Mwashuka. If someone didn't answer this, would have ended here. So there was booga coming from here. What did you mean? There was mean. So this was coming from this dude's nostril. And you guys can relate. This is June. Okay? And this is not good. And this is not good. So whenever you see this, just know it is bad. And the word bad comes with a negative sign. So this is going to be negative cosec. Okay. So in simple terms, on top we have sec, and tan. Below we have cosec, and cot. So picking, so here's the rule. Picking any two from a row gives us what is left as the answer. Picking any two from a row gives us what is left as the answer. Picking any two from a row gives us what is left as the answer. So if I pick the integral of the product of sec and sec, the answer is going to be what's left. The integral of cot and cosec, the answer is going to be what's left. So based on this rule, what do you think is the integral of sec squared x dx? This is a product of sec and sec. We said picking any two from any row gives you whatever is left as the answer. What do you think is the answer for the integral of sec squared x? Sec squared x is a product of sec and sec. So what do you think is the answer? Tan x. Chap, easy stuff. What push up? So the answer for this is going to be tan x. Good. But the integral of tan x is not sec squared x. So just from doing the integral of tan x, you understand? That's the one that gave us modulus of cos x plus c, whatever. What do you think is the integral of cosec x cot x? What do you think is the answer? Cosec, I've picked cosec and cot. What do you think is the answer? What do you think is the answer? Cosec x, cot x. What do you think is the answer according to this mnemonic? Good. whenever you pick any two, whatever is left, together with its sign, and the only one that has a sign is this part. So whenever you pick any two, whatever is left is your answer. Easy stuff. So the answer for integral of cosec x, cot x is going to be negative cosec x. Just like if I say integral of cosec, let me just show you this. Integral of cosec squared x is equal to, so I have picked cosec and I have picked cosec, but I haven't picked the negative. So the things that are left are the negative and the cot. So integral of cosec squared x is going to be negative cot x, and obviously you add your plus c plus c plus c. Hopefully you guys now get the mnemonic. Okay, so let's do an exam question. I was looking for an exam question. Fortunately, I have found it. Let's do an exam question. Okay, here is the exam question. Here is the exam question. Actually, before I go any further, what shape do we have here for this question? What is this shape? The polar equation r is equal to 2 minus 2 cos theta. What is this shape? What is this shape? The question we'll be doing is this, but what's this shape? What shape are we dealing with here? Quickly, you have a minute. What shape are we dealing with here? What shape under polar coordinates? We did polar coordinates recently. What shape are we dealing with here? What shape is this? This is a cardoid. Good. A cardoid in the x that is pointing to the negative side. Let's quickly try going through this paper so that you guys see that you're not as blank. Okay. So, anyway, I'll just pick a few things. These are just set theory, okay? This is an identity. We'll try it one day. This is induction. Induction is easy, you get? Now, this is the hardest question you ever meet under integration. This is the hardest question that you ever meet under integration. So. And we'll do it in the next session. So, Mulelo for F9. Mulelo, I'll do this question and it will come. Anyway, let's go. So, we have this equation. This will just become a quadratic. Okay, a log equation, you quickly solve, you change everything to the same base. This is binomial expansion, constant is as good as the independent term, you get. The derivative of tan, we did this. Derivative of tan, you're going to use quotient rule, okay. We're going to, this is what? This is first principles, basically, okay. Then Cramer's rule, we did Cramer's rule, fine. Remember, started from the bottom, blah, blah, blah. Then binary operations, this stuff is very easy. Then this is what? Hyperbolic functions. And then this is integration. Then when you do limits, you're going to understand this. You get? What else? Derivative of this with respect to x. There's something y appearing. So this is implicit. And whenever you differentiate implicitly, you're going to have a dy over dx. You don't make dy over dx a subject to a formula. We did this question under hyperbolic functions. If you remember, we replace sin hx with its identity, e to the power x minus e to the power negative x over 2. We replace cos x with its identity, e to the power x plus e to the power negative x over 2. And then you solve. At the end of the day, you need to introduce ln because you have e. Okay? Use De Moivre's theorem to find this. Okay? Convert this to its trigonometric form. And remember, De Moivre's theorem, the power is going to affect the r and is going to become the coefficient of theta throughout. Easy stuff. Okay, then I'm going to teach you how to integrate piecewise functions. We're going to introduce the concept of a breakpoint and so on, so don't worry. General solution, this will just cross over to the other side. You divide both sides by 2. General solution just means add n theta at the end of your answer. Okay, then find the center. This is a circle. You get easy stuff. Find dy over dx. Here, obviously, you may need to introduce logs so to get rid of the root. Okay, so perpendicular distance, we did this in one of the documents. Okay, solution, this is in functions. I think functions part 2 or part 3. Okay, inequalities. This will cross over, you find the what. Easy stuff. We've done all these things. These to my identities. Very easy. Okay. Now the question will be, and then we're going to do half angles. You'll be able to handle such very, very soon. Okay. Then this, they want you to convert it to its rectangular form. Fine. Yeah. Just replace, wherever you see theta, replace it with y. Wherever you see r, replace it with square root of x squared plus y squared, and you're done. Okay, now what are we doing? We are, this is also another question that requires us to use U substitution, this one. But anyway, let's answer what we are answering. Which one are we answering? We're answering this. Okay. So, mulelo fwa. When you hear there's a session, don't watch. So that in case it did win. Alright, so let's go. Find the integral of 5x minus 2 over x squared minus 4 dx. I'll be very fast. And I hope you guys have done partial fractions. There's a document on partial fractions. So those of you that joined us late, you should be doing these documents. Let's go. So this, you need to, so pointers. Use partial fractions. Okay, so you need to go to decompose this using partial fractions. Okay, so let me just focus on this first, and then I'll substitute it back in. So I'm going to have 5 minus 2 over, now x squared minus 4, this is the difference of two squares. This is going to be x minus 2, this is going to be x plus 2. Okay, these are linear factors. So this is going to be a over the first linear factor, x minus 2 plus b over second linear factor, x plus 2. Okay, you guys should know partial fractions, and I'm not teaching partial fractions. Then I'll multiply everything by the denominator of the main thing. So this is going to be x minus 2, x plus 2. This times that, the denominators just disappear. I'll be left with 5x minus 2 is equal to, whenever I have two denominators, they'll simply just swap. This is going to be a x plus 2 plus b x minus 2. Okay, then I start letting x be something. So in the first one, I'll let x be negative 2 so that the a can disappear. Negative 2. So wherever there's x, I'm going to put negative 2. So 5 times negative 2 is going to give me negative 10 minus 2 is equal to, this is going to be 0, because this is going to be negative 2 plus 2 is 0. So this will just disappear. 0 plus b. Wherever there's x, I'm going to put negative 2. So b is going to be negative 2 minus 2. Okay, this stuff is very easy. This is going to give us negative 12 is equal to negative 4b. This gives us b is equal to 3. We get the value of b. Okay, to get the value of a, I'm going to select x be equal to 2. Wherever there's x in this expression, I'm going to put 2. 5 times 2 is going to be 10, minus 2 is equal to, this is going to be 4a. Why do I say 4a? This would be 2 plus 2, and then 4, before will be written in front. This is going to become 0. 2 minus 2 is going to be 0. So plus 0. 8 minus 2, 10 minus 2 is going to give us 8. Divide by 4 is going to give us 2. So this is going to be 8 is equal to 4a, meaning a is equal to 2. So we've gotten a to be 2 and b to be 3. So wherever there's a, I'm going to put 2. Wherever there's b, I'm going to put 3. Easy stuff. So this expression becomes 2 over x minus 2 plus b was 3 over x plus 2. You get? So wherever I had this original expression, I'm going to replace it with the decomposed form. Okay? Easy stuff. I was fast on the partial fractions part because there's a document and you guys don't have any reason why you shouldn't have done the document. So basically, the integral of 5x minus 2 over x squared minus 4 dx is as good as finding the integral of the decomposed form, which is going to be 2 over x minus 2, 2 over x minus 2 plus 3 over x plus 2. Then we're going to have a dx. Okay, so integral of the whole thing is as good as integral of this, again integral of that. So this is going to be integral of 2 over x minus 2 dx. Okay, dx plus integral of 3 over x plus 2 dx. Now, the 2 and the 3 should be factored out. So we're going to have 2 integral of 1 over x minus 2 plus the 3 will be factored out, 3 integral of 1 over x plus 2. Don't forget to add a dx. Okay. Obviously, we're not going to use substitution, but this is one of the limitations of the power rule. You get? If you want, you can use the power rule, or you just recognize that the x minus 2, when it comes on top, is going to have a power of negative 1. What do you think is going to be the complete answer? What do you think is going to be the complete answer? What do you think is going to be the complete answer when you integrate this? When the x minus 2 comes on top, it's going to have a power of negative 1. So we'll just introduce ln. So what do you guys think is going to be the complete answer? In under how many seconds? 10 seconds. What do you think is going to be the answer? What do you think is going to be the answer? Quickly. What do you think is going to be the answer? Okay. So you are supposed to do the same for the other one. Good. So this is going to be 2 ln modulus of x minus 2, okay, plus 3 ln modulus of x plus 2. Then we add a plus c at the end. Easy stuff. Easy stuff. So if you don't understand partial fractions, you can't answer this question. If you don't understand the limitations of the power rule, you can't answer this question. You understand? Yeah. So that's that. That is that. I think this session is going to end here. We're going to have integration part 2. Yeah, the time will be communicated. So just be ready to go live at any time. Probably after 20, we'll communicate. Okay, have a good day. Please watch this video if there's any part you've not understood, especially when U substitution was introduced. Watch it, understand. Okay? If you've understood everything in this video, please look through the notes and start picking things that you don't yet understand. You get? Because everything prior to term 3 is required for you to have a full understanding of term 3. Okay? So have a good day. We will be in touch. Where can I find the document for calculus? Okay, so document for calculus. Let me see. Document for calculus. Where did I post it? Let me just look through. I think I sent the link. There should be a link saying math term 3. There should be a link saying math term 3. This link. Okay? There's a link saying math term 3, so just open it. Okay. So math term 3. You see it. So when you see all these names, you just scroll up and then you see it. You are going to see it. So matrices, there's trig, and there's calculus. These are the documents that I'm referring to. Okay, so go to math term 3, you understand, and go through the documents. There's a document on trig, document on calculus. All right, have a good day.